We're now going to go over the worksheet that's titled Stoichiometry Practice Worksheet that looks like this. Um, and I just want to go over the first two before asking, answers for the following questions. Like the first one, the first five of these ask to balance the following equations. And as you see, I already have the first two shown. What I want, just a reminder of what I need to do for balancing equations, I need every element to be the same on left and right side of the arrow. Here there is 2 nitrogens, 2 times 1 nitrogen. 3 times 2 fluorine or 6 fluorines, 2 times 3 fluorines. So that's 6 fluorines. So everything is balanced. I wrote the 1 here, though normally we don't write 1s, but I wrote the 1 so that you know it's not a 0. If there is no coefficient in the front, it's considered a 1. I wrote it, but again, normally we don't write 1s. Question number 2. Here's the coefficients of the balance equation. Just checking 2 times 6 is 12 carbons, 12 carbons. 2 times 10 is 20 hydrogens. 10 times 2 is 20 hydrogens. 17 times 2, what is that? 34 oxygens. 12 times 2 is 24, plus 10 more would be 34 oxygens. So everything's balanced. So I'll put up the answers for number 3, 4, and 5 now, so you can check. Here are the answers for questions number 3, 4, and 5. Okay, I want to go on to the next problem, number 6. Yes, I'm covering up some of the answers, or part of it, and I will, of course, go over it in a second. It says use the following equation, and it's given, and just so you know, the equations, when they're given, they will be balanced unless they are stated otherwise. Though normally you should check to make sure the equation is balanced. I'm just telling you it is balanced. So this equation here, by the way, this reads 2 moles of sodium hydroxide and 1 mole, this is called sulfuric acid, 1 mole sulfuric acid makes 2 moles of water and 1 mole sodium sulfate. That's what the equation says. So question is, how many grams of sodium sulfate will be formed if you start with 200 grams of sodium hydroxide, this thing, and you have given excess amount of sulfuric acid? So how many grams of sodium sulfate? So I put G, how many grams in question mark. So how many grams of that sodium sulfate given 200 grams of sodium hydroxide? It says excess sulfuric acid, that's sulfuric acid, meaning we don't have to worry about this being a limiting or excess reagent problem. I know I have plenty of it. How much do I have? I don't know, but I have plenty. That's why it's in excess. This is not a limiting or excess reagent problem. Okay, so this is, in other words, this is a grams to grams stoichiometry problem. So a given 200 grams, find how many grams of this thing, grams to grams stoichiometry problem. So when I'm given grams of, in this case, sodium hydroxide, we're given 200 grams of sodium hydroxide. First step, change it to moles. How to change to moles? Divide by the molar mass. Here I wrote the molar mass is 40. Okay, I did round. Where does 40 come from? From the periodic table. I didn't show the work, but it's sodium plus oxygen plus hydrogen added up is 40. Then I now know the ratio of sodium sulfate to sodium hydroxide is 1 to 2. Or you say sodium hydroxide to sodium sulfate is 2 to 1. I'm going to say it's 1 mole of sodium sulfate to 2 moles of sodium hydroxide. I put the 2 moles of sodium hydroxide in the denominator, so it'll cancel out. It produces 1 mole sodium sulfate. Again, the coefficient 1 and 2, that's where they come in. Then you would have moles of sodium sulfate. Though the question doesn't ask how many moles of sodium sulfate, the question is how many grams of sodium sulfate is the question. So, given moles, change it back into grams. I would have to multiply by the molar mass. The molar mass, I know I didn't show the work here, that would be by adding 2 sodiums on the periodic table, 1 sulfur, and 4 oxygens. I added and I got 142.04. Again, these numbers are rounded, so if you have more digits or a little bit less, don't worry about that too much. Though rules of significant figures technically apply at the end. Okay, so what answer did you get? It should be 200 divided by 40 divided by 2 times 142. I got 355. Um, if you want to be technical and say, hey, shouldn't this be 1 sig fig, then fine, 400 grams. Probably be more correct, but let's not worry about sig figs for this thing right now. Okay, question number 7 is kind of the same thing, just another equation, but the same, similar kind of problem in that this is yet another gram-to-gram stoichiometry problem. Why do I say that? Here's the balance equation. It's already given. Question's how many grams? So I want to find grams of lithium nitrate. That's lithium nitrate. Question, how many grams of this thing will be needed to make 250 grams of lithium sulfate? So to make 250 grams of it, how many grams of lithium nitrate do I need? And it says, assuming you have adequate amount of lead sulfate, lead 4 sulfate. So this is an excess reagent. We're not worrying about limiting our excess reagents here. So 250 grams of this makes how many grams of this do I need? All I know from the equation is 4:2 ratio, mole ratio. It's currently given as grams. First step, change grams to moles by dividing by molar mass. Again, molar mass, that's 2 lithiums, 1 sulfur, 4 oxygens, is 109.9. Then, as I just said, it's a 4:2 ratio. 4 moles of lithium nitrate, 2 moles of lithium sulfate. Coefficient 4, coefficient 2 from the balanced equation. Next thing, then you have moles of lithium nitrate. The question isn't how many moles, this is how many grams of lithium nitrate. So one more step, multiply by the molar mass of lithium nitrate. The molar mass of lithium nitrate I got in my calculator was 68.95. That's a lithium, a nitrogen, and 3 oxygens added up. What do you get on a calculator for this whole thing? And I got 313.7. If you want to be technical, again, 2 sig figs, 4 sig figs. These are, 2 to 4, these are infinite sig figs, because those are whole numbers, exactly 2 to 4. But 2 sig figs would, I guess it'd technically be 310. And let's not worry about rounding for this stuff right now. But rules of significant figures technically apply. But you won't be penalized for rounding or anything like that. Okay, I want to show you the answers from number 8 and 9, which are actually kind of very challenging problems. That is a limiting excess reagent problem. How do I even know? Well, let's read the question first. The equation, 2 moles of this C6H10 reacts with 17 moles of oxygen, making 12 moles of carbon dioxide and 10 moles of water. It says, in this reaction, 35 grams of C6H10 and 45 grams of oxygen react. How many grams of carbon dioxide will form? Before you're like, well, which one do you start with? You first actually kind of have to do number 9. Figure out what is the limiting reagent in problem. By the way, should said they're all problem 8. So question number 9, 10, 11 is based on, obviously, this one right here, problem 8. So what is the limiting reagent? I know I wrote oxygen. It is, but we first need to figure out how. How I do it is this. Let's just say, I know I have 45 grams of oxygen, but how much do I actually need? I know I calculated it right there. Meaning, let's say you didn't know you had 45 grams of oxygen. Let's figure out how much oxygen you actually need in this reaction. Well, then it's a grams to grams stoichiometry problem. Start with 35 grams of C6H6, change it to moles by dividing by molar mass on a periodic table. Then I know it's a 17:2 ratio, 17:2 ratio, 17 moles of oxygen, 2 moles of C6H6, and then a mole of oxygen, O2. 2 times oxygen is 32 in a periodic table, and I got 115.9, almost 116. What that means is if I had 35 grams of C6H10, I would need 115 grams of oxygen to react with all 35 grams of C6H10. Well, that's how much I need. How much do I really have? I have 45. You have 45, but you need 115. What that means is you don't have enough oxygen, meaning oxygen is your limiting reagent. So that's how I got number 9 first. So oxygen is the limiting reagent. To figure out how much product I can make, which is in this question, how much carbon dioxide will form. Carbon dioxide is a product. I always use the limiting reagent. Always use the limiting reagent to solve a limiting reagent problem. It's kind of like if you have a recipe and you're trying to figure out how many cookies you can make at home, you need to first figure out which ingredient is going to be the one that runs out first. Or if you have an ingredient that you might not even have at home. In that case, you wouldn't be able to make the recipe. So you need to figure out what is the limiting reagent. In this case, I found it to be oxygen. Use the limiting reagent, in this case oxygen, my 45 grams of oxygen, to answer the question. So using my limiting reagent, 45 grams of oxygen, use it to solve for how many grams of carbon dioxide. Change grams to moles, molar mass of oxygen is 32. The ratio of carbon dioxide to oxygen is 12 to 17. 12 moles of carbon dioxide is 17 moles of oxygen. Then change my moles back into grams. 1 mole of carbon dioxide weighs 44.01 grams. That's 1 carbon and 2 oxygens on the periodic table. And the only thing left are grams. 43.7 grams of carbon dioxide. I do realize these are some of the hardest problems in this whole chapter. Probably some of the harder ones that you've done in chemistry, in stoichiometry so far. Okay, question number 10. The question says, how much excess reagent is left over? Okay, well, first of all, oxygen's the limiting reagent. That means C6H6 is my excess reagent. What it's saying is, okay, well, I know this thing's going to run out. That's my limiting reagent. And I know this thing I'll have extra of. How much extra will I have? If I use all 45 grams of oxygen, how many grams of C6H10 will I have? Or, well, will I have used? And to calculate that, this is what I did. I took my 45 grams of oxygen, that was my given, and calculated how many grams of C6H10 I need. So yet another stoichiometry problem. Change my grams to moles, then it's a 2 to 17 ratio. My moles back into gram, molar mass of C6H10 is 82. And I calculated for 45 grams of oxygen, I need to use 13.6 grams of C6H10. I will use 13.6. Okay, well, if you use 13.6 and you had 35, how much is left over? It will be 35 minus 13, because I will use 13.6, and I had, it's up here, I had 35. I had 35, I will use 13 of them. What's left? Well, subtract, or 21.4 grams of C6H10 left over. Don't worry about rounding sig figs for this one. Okay, so that was number 10. Number 11, if 35 grams of carbon dioxide is actually used, I'll put up the whole answer. If 35 grams of carbon dioxide is actually formed in a reaction, problem 8, what is the percent yield in the reaction? The equation for percent yield, actual yield divided by theoretical yield times 100. So it says if 35 grams are actually formed, so the actual yield is 35 because it says so. Well, how much could I have made? Well, that number was back in question number 8. This amount is my theoretical yield. That's how much I could, that's how much I calculated I could produce. It's 43.7. So 43.7 is my theoretical yield. That's what my calculated yield. Theoretical yield and calculated yield is also known as a calculated yield. So 35 divided by 43.7 times 100 is 80%. 80.1%. Continuing on, number 12 says write the balance equation between acetic acid with aluminum hydroxide to form water and aluminum acetate. Okay, this I would just tell you now, I would give you this on a test. You would not have to write your own equation. But here it is, balance. 3 moles of this is called acetic acid, 2 moles of aluminum hydroxide makes 3 moles of water and 2 moles of aluminum acetate. Okay, let's not worry about that right now. Again, the equation would be given to you on a test. Okay, but given that, let's do number 13. Using that equation here for number 12, determine the mass of aluminum acetate, that's this last thing here, aluminum acetate, that can be made in this reaction with 125 grams of acetic acid, this thing, and 275 grams of aluminum hydroxide. So we're given 125 grams of this and 275 grams of the other thing. One of these two things runs out first, and I wrote it on here, but I covered it up on purpose. Okay, so I need to figure out which of those two things runs out first. Is it the 125 grams of acetic acid, or is it my 275 grams of aluminum hydroxide? Well, I can either, what I did was I took my 125 grams of acetic acid and calculated how many grams of aluminum hydroxide I need. I know I have 275, but how much do I need if I had 125 grams of HC2H3O2? And from there, that's just a normal, shouldn't say normal, but it is kind of just a regular stoichiometry problem. What I mean by that is, what you have to do is change your, oh, here's all that work, change my grams to moles, divide by molar mass, which was 60. Then I know it's a 1 to 3 mole ratio. 1 mole aluminum hydroxide is 3 moles of acetic acid. Then change my moles back into grams. And on my calculator, what I got was 54.12 grams of aluminum hydroxide needed. Okay, so I need 54 grams of aluminum hydroxide. You have 275 grams of aluminum hydroxide. You need 54. You have 275. You need 54. You have 275. Does that mean aluminum hydroxide is a limiting or excess reagent? So aluminum hydroxide is my excess reagent because I only need 54 and you have 275. If I had $275 in my wallet and I wanted to buy something and it costs $54, I have excess money. So this thing, aluminum hydroxide, is in excess. Or if this thing's in excess, the acetic acid is my limiting reagent. If this thing runs out, if I have extra of this thing, the other substance will be the substance that runs out first. And to do the problem, I didn't actually answer the question yet. To answer the question, always use the limiting reagent, in this case, acetic acid, to solve the question. Always use the limiting reagent, in this case, 125 grams of acetic acid, to answer the question of how much aluminum, aluminum acetate I need. And change my grams to moles. It's a 1 to 3 mole ratio. 1 mole of aluminum acetate is 3 moles of acetic acid. And then grams to moles. Moles to grams. Moles, find the molar mass of aluminum acetate. And on my calculator, I got, will be 125 divided by 60 divided by 3 times 204, and I got 141.6 grams of aluminum acetate. Again, I know this is probably one of the more challenging problems. Oh, we already answered question number 14. What's the limiting reagent? Aluminum acetate, well, the HC2H3O2. Sorry, acetic acid. That's right there. That's called acetic acid. That thing runs out first. Okay, last question. How much excess reagent will be left over in question number 13 after the reaction is complete? Remember, I had 275 grams of aluminum, aluminum hydroxide. aluminum hydroxide was my excess reagent. Aluminum hydroxide is my excess reagent. I had 275 grams of my excess reagent. How much did I need, or how much will I use? 54 grams. If you had 275 and you needed use 54 of it, what's left? It'll be 275 minus 54, or 221, okay, rounding, 220.88. Again, don't worry about rounding right now, or sig figs. But I start with 275, I use 54, and I'll have 220-ish grams of aluminum hydroxide left. Okay, so I realize this is limiting excess reagent. The last two pages are some of the hardest types of problems, but they're also important, and I think they're fun concepts as well.